Hi everybody, Adam here. Welcome back. In today's video, we are continuing on with the farmer was replaced. We're going to see if we can make a push through the rest of the game here. I think that with a little bit of editing, we should be able to fit all that in because I feel like we're on a pretty good path here. Really been enjoying this. I think it's an interesting way to learn programming or sort of refine some of your programming knowledge. So where we're at now, we've unlocked operators, which should be really cool. And if we look over here on the unlocks, we've got we need more wood so that we can unlock debugging. Really nice depth of tech tree here. Lots of cool stuff to unlock. So let's go back to the farm. And I think we've got everything we need to know there. So if we start running this again, let's see, are we gaining? We're actually gaining wood anymore, or are we pretty much just gaining hay and carrots? Pretty much, let's see, so we're going to go through the hay here, and then now we should be, that wood basically gets used up immediately in the planting of the carrots, which is okay, but let's let this move one more time through the loop here, and then let's try something a little different. Yeah, so we're gaining lots of hay, lots of carrots. So we're going to reset to that point, and then let's start a new code window. And we're going to call this need more logs. So now, if we were to come and take what we were doing over here, this was the everything window, and now we're going to want to be a little more nuanced. You're going to do that. That's not really what I wanted. Did you? That is weird. I understand, but okay. So let's see if we can make this a little bigger. If we go and paste everything in there, but then if we go and we pretty much remove everything that's not getting us, no, that's not what I wanted, for, yeah, like that. And then do the same thing down here, get rid of the carrots. So we still want our everything or do everything file, but this will let us, once we get through this first batch of hay, we should be able to just start cranking up the numbers that we have for logs. Yes. So that is what I feel like we're going to need a little bit more of, is just the grab resource X so that we can just move quickly through some of the unlocks that we have on the tech tree board there. Really cool to see though. I love the interaction here between the code and your little farming area. I think they've done a really good job. I know it's not like Python specifically, but I think they've done a really good job of their sort of custom, almost Python code and compilation there and tying it into the gameplay. Works really well, really intuitive. Let's see, so we want to increase speed. That sounds like a good thing. can increase the speed even more. I think we want, no, now I'm kind of torn. Let's do that one more time. So now we must be going uber fast. Any faster and we would probably not have crops ready to harvest. So I think that's a pretty optimal point that we're at. So now if we go here, we can unlock debugging. That's being funny because the window's there. So debug, sometimes your code just doesn't work and you need to find out why. There are a couple of tools to help you do that. The first is to execute the program step by step. You can go into step-by-step mode with the button next to the execute button. So the not filled in, yeah. Or by setting a breakpoint. Breakpoints can be added by clicking on the breakpoint panel to the left of the code. So the little line out here, or this little column out here, basically. So you can see we set a breakpoint. I is 3. Will it calculate? I don't think it's going to tell us what get world size is. No. That's cool though. So we're on I is 3 and J is 2. So this goes and executes a step in the code. I is to 0 now. Okay, that's cool. I don't think we need anything more there right now. We can just let that go back to doing its thing. But that's powerful functionality. When execution reaches the line with the breakpoint, yeah, we switched. When you move your mouse over available, yeah, we saw the current value. The print function can also be very useful. Oh, that's cool. Print functionality, always super useful in tracking issues down. I see, okay. Into the air and to the output page. Output is also written to the game folder. Yeah, that's cool. I dig it. Really, really nice functionality. Now, what else have we got going on here? How about watering? Plants grow faster when they are watered. The ground has a water level ranging from 0 to 1. Function get water returns the water level of the ground it is over. Growth speed of plants scales linear from 1x at water level 0 to 5x at water level 1. So that all seems good. These water tanks, one water tank is automatically added to your inventory every 10 seconds. Upgrading unlocks watering will give you an additional water tank every 10 seconds. A tank holds 0.25 water. So we can do use items. Okay, so let's try stopping this. We can call use item items.water over the ground to water the ground. Now I'm curious if we go, what if we went and just did this? So we can say use item, is it entities? Nope, it was just the items dot, yeah, so not, okay, I see. So we got items dot water. So I'm curious, this is probably going to result in us, we're going to try to water probably in a number of situations and we won't be able to. Let's do the reset here just so that we can see it working 100%. So we're theoretically watering, but we're not doing very effective watering because we only get water every so often. So you can see the water level of the ground. I don't know if we can see how much water we actually have, though. Interesting. So we could do something like this. We could say if, how do that? So we say if get water is less than 0.5, then we can do the water like that. Theoretically, that should work. Reset. Hard for me to see whether it's actually watering, but I think it is. You can see the splashes of drops every now and then. Yeah, so it's definitely not storing any up. Because otherwise we'd see that number hitting more than one on occasion. So if we go, so I'm curious, if we go over here, we can unlock more water, more water, and more water, and more water, and more water. So we should be at 0.6 water per second. So if we go back here, if we reset, we are basically always watering. We haven't reached the point where we have more water coming in than going out. Yeah, okay, so then the water just builds up over time. If we go, curious, how much is the next one? So 323. Can increase the yield of grass, trees, something we can unlock. Fertilizer. Grow plants instantly. That's funny. So you just basically stay on the one spot, really. We can expand the farm, but we can't until we get pumpkins. And pumpkins are after trees. Maybe trees are a good place to go. Trees are a better way to get wood than bushes. They give 5 wood each. Like bushes, they can be planted on grass or soil. Trees like to have some space, and planting them right next to each other will slow down their growth. The growing time is doubled for each tree that is on a tile directly to the northeast, west, south of it. So if you plant trees on every tile, they will take 16 times longer to grow. Interesting. So we kind of want to alternate them. It's kind of what I feel like it's telling us. Do we want to? If we come up here, it really wants to display them, tile them that way, doesn't it? So if we go here and if we go we copy all of that, and if we make a curious whether these trees are going to be worth it or if they're going to be more bother. Um, so let's call this trees, and let's call this trees and hay, because I think what we're going to want to do is we're going to want to alternate based on what they said. I don't think we'll start there. I think we'll start there, but we'll try that just trees on their own up front. Yeah, they're pretty slow. Pretty slow. You can see the first ones were faster than the last ones. Now, so if we were to go, question is, how do we want to, because this will basically go through and it'll do everything. If we said, that if, let's do this, so we can say if. So basically what I want to do is I want to alternate. So I'm thinking whether I want to just alternate on the row or if I want to alternate on the column as well. But let's do this first. We can say if I equals 0, parentheses there, I don't think, but I think we should be able to do this. If we said it's that, then we do this, else plant entities dot grass. So what I'm aiming to do here is basically if we're on an even I, then we'll plant a tree, and if we're odd, then we should plant grass. See if that, no. Oh yes, because we need the colon. Okay, that worked. So that was the basic of what I was doing. So this is still not ideal because they still have trees. Everything except for the first and last column has 2 trees beside it. But that is closer to what I wanted. That is not too bad. So if we said if J is even as well, so we say if J is even and I is even, we do a tree. Else if J is, I think we want to break this into 2, or at least 4, oh, I didn't fill that all the way up. So let's do if J is even, then we can say if I is even, we will plant a tree. Else we will plant grass. And then we say else, J is going to be odd. If J is odd, then we say if I is even, then we want to be doing grass, else we will plant a tree. So what this should end up doing in the first column, we should be tree, grass, tree, grass. In the odd ones, like the second column there, we should be grass, tree, grass, tree. So theoretically, things should be growing optimally because they shouldn't have duplicates. So that is working the way we want it to. So that is efficient. We've basically gone and alternated things in a nice way so that we don't have trees beside trees on a horizontal or vertical direct, only on the diagonals do they connect. We could make that code a little cleaner probably, but I think that'll be fine. That's straightforward and it just makes it easier to understand what's happening. We're accruing a lot of resources, so we must be basically watering all the time. We're watering whenever we watering whenever we need to, at least. I don't think there should be any barriers on water at this point. Yeah, it is doing the watering still. So that is good. So we're using the operators pretty efficient now when it comes to, yeah, we've stacked up a lot of wood there. Pumpkins. We're gonna need more. We're gonna need more carrots. So let's see, what else do we want to do here? Functions to temporarily slow down the execution and make the grid smaller. Okay, that's cool. Timing is pumpkins. Drone can see what's under it and where it is. Assign values to variables. Interesting. So pumpkins is really the thing now, and carrots, it looks like. Do that. Can't do that yet. So that increased the yield of our grass. So grass will be much more effective now. So if we go back to our farm, I think let's copy all of this. So I think what we want now is we're going to want carrots. What? Where'd you go? Why are you so interested in docking on things? So if we go here and we basically, let's paste that in. So we want carrots. So we're going to get rid of that first chunk. Okay, so we can get rid of the J as well. Then if we basically remove that because we don't want bushes, we're just going for the carrots. There, so that should get us just carrots. Isn't enough indentation? Oh, because we are, yeah, you should go back one more. That'll be good. Allow things to, okay, you really like that, okay. So let's go, oh, I know what we can do to make this. Let's go like this. Let's get ourselves reset. And then let's do some carrots. the, yeah, so I feel like this is what it's going to be now for a bunch of the time, is just trying to grab huge quantities of specific resources to try to meet some of the thresholds that we need to. So it shouldn't be bad, but like I said, it might be a little time consuming. What is the number that we're looking for here? So we can get 350 for pumpkins. It's probably the best way to go. Sunflowers and power. Fertilizer is cool, but I don't need things to grow that fast, I don't think. Not yet, anyways. I mean, I guess you save the movement speed. Is that what they're trying to aim for? So we need 350. Come on, 350. Now it's getting slightly confused because it's not getting to things at the right time. Like things aren't completely finished when it gets there. Which is fine. Increase the yield. It's probably a good thing. If we get more carrots, more bang for our buck. We need pumpkins though. We need pumpkins. Oh, and now we need lumber logs. So let's go and run this one again. Actually, let's do this. Let's reset. Get you sorted out. Run this. And that should let us get the pumpkins really quickly here. You get to 500. We're almost there. Not too bad picking up all the different resources as you start to optimize the yield. Makes things go much faster. Pumpkins grow like carrots on tilled soil. Planting them costs carrots. When all the pumpkins in a square are fully grown, they will grow together to form a giant pumpkin. Unfortunately, pumpkins have a 20% chance of dying once they are fully grown, so you will need to replant the dead ones if you want them to merge. That's annoying. The yield of a giant pumpkin depends on the size of the pumpkin. A 1 by 1 pumpkin yields 1. A 2 by 2 pumpkin yields 8. I see. A 3 by 3 pumpkin yields 27. 4 by 4 pumpkin yields 64. I see. So we need, the dying thing is annoying. Okay, so we're gonna need a bunch of carrots. So let's reset. Let's get the carrots going, and then let's add a pumpkin code section here. So pumpkin. So if we go in here and we just copy all of that, we bring that all down into pumpkins, and we go and if plant move north else. Yeah, that should be fine. So we're going to be working on pumpkins. Pumpkin. What are we at in terms of our, a lot of carrots built up. Let's see, if we reset, can we grow pumpkins? So we missed spots. Why did we miss spots? So if we can harvest, we do that. I see. So if we get to a spot where we have not, so if we can't harvest, I think I love this, but let's see if we go, because I really want to, I think we're going to need sensing. That's what I feel like. We need to see what is underneath. Need to see what is underneath, but we can do this to start. Reset. We're harvesting. We're not necessarily. It's interesting. I feel like we should be planting all the time. I don't feel like there's really a way to not plant. But clearly we're missing the ability to plant in some spaces. If we were to step harvest. Should plant, yes. Curious why we're getting the are we if it's that. I wonder if we're tilling and then we do that. So now if we reset, I think it's changing it from the dirt back to the grass, the green ground rather than the tilled ground, which is causing issues. Let's see what we get here. So sometimes they die. Yeah, that works. Okay, so it was the till was putting it into the wrong state, which was then meaning that it couldn't plant the pumpkins, and that meant that it grew the grass, at which point it could then turn the ground back into the dirt for an actual pumpkin to grow. So this is not getting us any of the optimal state pumpkins, but we are getting a lot of pumpkins. So that is good because we do need pumpkins. But as you can see, it is using up our carrots pretty aggressively. I think that's okay for the time being though. So let's stop there. Let's reset things. And then in terms of unlocks, what do we want to do? Do we want to expand? 5 by 5. 5 by 5 is large, but that should be good. So if we were to run the trees and hay here, does everything still work? It should, but never assume. Yeah, happy with that. That's getting us more stuff. Okay, I'm going to cut here. You guys will see when we're back in just a moment. You guys will see us with a lot more resources because we're going to run a bunch of stuff just to stockpile so we can make more progress at a greater clip. but happy with how these are, happy with how our functions or our files here are executing. It's now really just a case of just running things long enough to stockpile resources for unlocking and moving on. And we're back. So I think we've racked up a good amount of resources here. Let's see what we can do. Can we do that? Let's unlock sunflowers. Sunflowers collect the power of the sun. You can harvest that power. Planting them works exactly like planting carrots or pumpkins. Harvesting a grown sunflower yields power. If there are at least 10 sunflowers on the farm and you harvest the one with the largest number of petals, you get 5 times more power. Measure returns the number of petals of the sunflower under the drone. Sunflowers have at least 7 and at most 15. They can already be measured before they are fully grown. Several sunflowers can have the same number of petals, so there can be several sunflowers with the largest number. As long as you have power, the drone will use it to run twice as fast. It consumes 1 power every 30 actions. Executing other code statements can also use power, but a lot less than drone actions. In general, everything that is sped up by speed upgrades is also sped up by power. Interesting. So we can measure. I wonder if you really want to do much measuring though. So if we go Control A, Control C, let's bring out this, and let's call this sunflowers. So we do sunflower and sunflower and sunflower. So if we just run that, where are we at? Okay, we're growing the sunflowers. Then we want to be able to start harvesting those. Okay, yeah, and then you can see we've got a new resource, power. So we're probably not being super efficient with the creation of this because we're jumping around all over the place. But we are getting power, which will make the drone go faster. So that is a good thing, I think, generally. Power doesn't go away once you've got it, so that is a good thing. Let's grab variables. Variables can be thought of as named containers that can hold a value, equals operator. So these are all just pretty standard. Can use it for counting our way through loops. All pretty standard stuff. Okay, I don't know that we need those yet. I guess we'll see. If we come back here, well, let's look at the unlocks again. What do we need? Could expand the farm again to 6 by 6. We've got the potential. We've got power for functions. We've got lists and senses. Senses, I think, is going to be cool. Do fertilizer. At some point, waiting for the plants to grow is just not efficient enough anymore. Similar to water, you will automatically receive 1 fertilizer every 10 seconds, plus an extra 1 for each upgrade. Reduces the remaining grow time of the plant under the drone by 2 seconds. Plants grown with fertilizer will be infected. When a plant is infected, half of its yield is turned into weird substance when it is harvested. Weird substance can also be used on plants, which has the effect of toggling the infected status of the plant and the adjacent plants. So if you call use items.weird substance on an infected plant, it will cure it. But if you use it on a healthy plant, it will infect it. Wow, I don't know, that's weird. Weird, weird, weird. I don't know how useful that really is. I get the sentiment and what they're trying to do. Get the sentiment. So we're about to get items.weird substance. I guess that's what this is. No, that's fertilizer. So if we go over here, if every time we plant, we go and use the fertilizer. So we're now accumulating weird substance. Yeah, that's, that is literally weird. I don't know. I don't know how wonderful that is. I mean, we're doing stuff, but I don't know if I want to. I mean, that's just the efficiency of that. Like the fact that you have to be constantly checking then the poison state, that you can heal one thing from being poisoned, but then convert everything else to be poisoned around it. I don't know, man. I'm not sure that is cool or not. Let's grab. We need a lot of pumpkins. A lot of pumpkins. Can bump the drone speed. We can bump the yield of grass. We can expand. What is that resource? Interesting. Can increase the yield on our carrots. Yeah, we're just going to need a whole ton of, let's reset this so you can see what's going on again. The drone's moving so fast, like you pretty much can't even see it anymore. That is doing what we want, though, because we need a whole bunch of those so that we can make a whole bunch of carrots, so we can make a whole bunch of pumpkins, so that we can unlock a whole bunch of stuff. So you can see what I mean when I said, like, we're definitely into this phase now where it's like really about grinding out materials to do stuff, not necessarily a lot of complexity in the problems that are being solved. Although there's definitely some opportunity for us to go and try to finesse some stuff around the fertilizer and the weird substance, but I think for now we're just going to push on trying to do these unlocks. So we'll stop there. I'm going to, through the power of editing, We'll be back in just mere moments, and we'll see if we can have enough pumpkins to really move forward on unlocking that next wave of unlocks, basically functionality that we can unlock in that tech tree. So see you guys in a moment. And we're back, continuing to rack up resources here to unlock more things. Let's see what we can do now. We should probably just do the senses. Clear that one off so the drone can see what's under it and where it is. So we can do the get position, X and Y, return the current X and Y position of the drone. At the start position, they are both 0. The X position increases by 1 for every tile towards the east. And the Y position increases by 1 tile, or by 1 every tile to the north. So north and then east is going over this way. Num items returns how many of an item you have. For example, num items hay returns how much hay. So you know what we could end up probably doing is we could amalgamate some of these separate files in together and just put some logic for how to farm up the resources we need. And then if you wanted to say what you're on top of or above, so get entity type, get ground type. So you can say get entity type, entities bush, do a flip. The none keyword is also unlocked now. No value, so get entity type. Oh, none if there's no entity under the drone. That's kind of cool. I like that. I'm curious. Okay, let's take that off to the side. I think we're going to come back to that because, like I said, I feel like we can do some fancy stuff here now and start to amalgamate these things together. So if we go back to the unlocks, timing, 1,000 pumpkins. Well, let's see. Let's do the functions. So if we do 80 carrots, we can do 80 carrots. Define your own functions. Use the DEF keyword to define a new function. So def function arguments. You can now use the call operator to call the function. Also see scopes to learn about local and global variables in functions. Yeah, so you could have it move several times in a direction, or what I'm thinking is that we're going to do this for maybe some of our functionality. We can group it, so you can do return values. Yes, that'll make sense. That's cool. Default arguments. It's impressive. There's a lot of functionality that they have packed into this game. I'm curious how far they had to go in writing their compiler basically to run this, because I'm pretty sure they're not, I might be wrong, they might be leveraging something completely out of the box, but I have a feeling they've gone and written everything underneath for supporting all these different all the different code items here, or code functionality. So if we were So I'm curious if we go and if we were to stop that. So if we popped that window back open, make this bigger. So we could go and we could define a function basically. So we could say, actually, do we do it? curious whether I need to put my function at the start or at the bottom or where I put it relative to the code that we have there already on the screen. But so if we do def, let's call this trees and hey, don't need to take any arguments. Okay, they're kind of treating this like it's a, so if we come here, so if we go and take this all out of there, so if we go Control X, and if we just pasted that all in there, then theoretically we could call trees and hay. Okay. So we need to define, so that's what I was wondering. I was wondering, it's like, where do I have to put this in the file? Does it have to be above the code or can it be anywhere? And the answer is it needs to be above, which makes sense because then it goes through, it looks, grabs all of that and then internalizes it in a way that it can then be called down here. So we've got our function that does our trees and hay. And we said that we could do a num items. So we can do, so let's stop this. Let's define another function. Let's do let's make that more verbose. The name so that we know what these are doing. I think we probably would have been fine with what we had before, but now that I'm writing more, I'm just going to make this nice and easy to read. So we're going to have a new function, carrots, grow, and harvest, which is going to basically do, I don't want the while loops. So if we copy that, paste that in there. I don't want the while loops because I don't want it to stay just inside the function forever. So now, theoretically, we could say that if get, or just if num items items dot, is it would? Yeah. If number of items would is less than, what do we want to do this as? If it's less than 1,000, okay, we'll say less than 1,000 for now. So if it's less than 1,000, harvest else, and that'll basically go and it'll run through the whole board once then if the wood is less than 1,000, so it won't just run until the wood gets to 1,000. It'll probably go over by some number. But else we can say carrots grow and harvest. So if we reset that, run that, so we're going to run through basically and do carrots now. until we drive the wood numbers down below 1,000, which would be, it's going to be a long time, but I think that's okay. So let's permanently delete the carrot file. Yes, we want to do that. Because this is going to, see, the nice thing about this is basically I can get to the point where I could just kind of let this run on its own if I wanted to farm a bunch of these things out. So we got mega stuff harvesting. What if we go over here? Can we, things I'm interested in. So I'd like to increase the yield of pumpkins, I think, because we're going to need a lot of those. So we're going to need to get efficient. I think we can get more yield on our carrots. That is a good thing. Oh yeah, we're down low enough on the wood now that we can't keep going there. Don't know what that is. Go higher on the speed of the drone. It's probably the cactus one. We can increase the yield of grass by a lot. And we can probably get timing next. So we're just going to let that kind of tinker away in the background while we look at what timing does. But we're starting to get towards the 1,000 mark for the wood there. So I think we're going to, yeah, we're going to come here. Now it's going to start going and doing the trees and the grass, the hay. That is a good thing. It's going to work its way through that, and then it's going to toggle back in a moment. It's going to toggle back to carrots. Then it's going to, yeah, now it'll kick back over to the wood. Yeah, so that's working like we want it to. I'm happy with that. I think we can add some more logic there, but let's see here. So timing, if you really want to optimize your methods, you need to understand how time is measured in this game. This unlock is all about that. 2 new functions. Get time returns the time in seconds since the start of the game. Get tick count returns the number of ticks performed since the start of execution. These 2 functions, as well as quick print, are completely free. Even the call operation is free for them. This is not how performance works in the real world. Yeah, no freebies quite like this. These are just rules made up for this game, since you have a consistent and understandable timing model. So it's talking about the operators there for combining 2 values. Take 1 tick to run. If branch also takes 1 tick to run. Import statements are free. That's cool. That's cool. I'm sure we can do some stuff eventually here to optimize based off of that, but interesting the level of thought and detail they have gone to with putting all of this functionality in. Now we really want to increasing our numbers nicely, but I feel like we want to go, let's reset everything. So I want pumpkin functionality. So if we go here and we bring this part over, so if we go define pumpkin, grow and harvest, And then we paste that in. So we should be able to permanently delete that. Yes, that's fine. We can always recreate it if we needed to, but now I can say, I think I might change the way this is a bit. Well, no, so let's see. So if wood is less than 1,000, we need to do that because that is required for this. So if wood is not, then we can say else. We can do else if num items dot caret is less than 1,000. Then we can do the carets. And we'll do pumpkins down here because they're the last thing in the chain at the moment. So we do wood if we need it. Well, hay and wood if we need it. Otherwise, we do carrots if we need them. Else, we do the pumpkins because we need some mega pumpkin numbers. Mega pumpkin numbers to make this, or to basically advance ourselves on farther into the game, because we need some mega thousands. But this is going up pretty fast, more than pretty fast. It's going up super fast. So if we look here, yeah, we're gonna hit these targets for the pumpkins pretty quick. So I think 3,000 was one of the, let's see, 4,000 for the cactus, 4,000 for the dinosaurs, 3,000 for the maze, which will get us the treasure, which I feel like was the, what is that? The treasures here for the debug 2. That's good to know. Yeah, everything's starting to need treasure or pumpkins. So we are over the 4,000. So let's grab cactus. Move this over here while we read this and while that stuff's going in the background. Like other plants, cacti can be grown on soil and harvested as usual. However, they come in various sizes and have a strange sense of order. If you harvest a fully grown cactus and all neighboring cacti are in sorted order, it will also harvest all neighboring cacti recursively. A cactus is considered to be in sorted order if all neighboring cacti to the north and east are fully grown and larger or equal in size, and all neighboring cacti to the south and west are fully grown and smaller or equal in size. The harvest will only spread if all adjacent cacti are fully grown and in sorted order. This means that if a square of grown cacti is sorted by size and you harvest one cactus, it will harvest the entire square. You will receive cactus equal to the number of harvested cacti squared. So if you harvest n cacti simultaneously, you will receive n squared items.cactus. The size of a cactus can be measured with measure. It is always one of these numbers. You can also pass a direction into measure to measure the neighboring tile in that direction of the drone. You can swap a cactus with its neighbor in any direction using the swap command. Swap direction swaps the object under the drone with the object one tile in the direction of the drone. Wow. Okay. That was a level of complexity I did not see this going to. So let's stop this for a second. Let's reset this. So So yeah, so we need to do, so if we go, so if I wanted to, we should be able to go here and we should be able to copy that. Hello? No? You can't? Okay, there we go. So if we come down here, let's just make a new file. Let's go and figure out the world of cacti. Cactus, grow, sort. So if we, no, not what I was looking to do. So if we come here, so if we come in here and let's see, so we don't want to do a while loop, at least initially. So basically we just want to go through each, we're not going to be looking at any harvesting here. We just want to plant cactus. And we're going to do that plant, move north. And then when the time comes, we will move east. So theoretically, this should just go and it should plant. It should go and just plant. No, it needs the harvest. Okay. So we can say if can harvest, then harvest. So that did the harvest, but it didn't do the plant. Why did it not do the plant? Do we need to, I don't think do we need to till the ground? Let's try. There we go. So we needed that till. Now this is where it gets funky. So we want all the ones to the north to be so I'm curious if we go, so let's do so if we grab this and if we copy that, so let's do this as cactus sorting. So if we step through, and if we say, so we can do measure, so if we go, I like and well-intentioned, but that's annoying. I don't like how it tries to clamp everything. So if we go in, we don't need to do int, right? We can just do current. Or do we? Where's our variables? Variables. Functions. We can close that. Did we do assigning? Yeah, we did assigning to variables. some variables. So we don't need to do any typing. We can just do okay. We can just name and go equals. So we say current cacti size equals measure. And we can say to the north, we can say north cacti size equals measure, and direction is going to be, just do north. Do north. Then we can say if north cacti size, actually put that in brackets, but it probably would have been fine. Let's see, cacti size. North cacti size is less than current cacti size. Then we want to do a swap. What's the syntax on the swap directions? We can do swap north. Yes, I know what you want to do. Too difficult for me here. So then we make this a little bit bigger. We can get rid of the harvesting, the tilling. We can get rid of the planting. And then so we will move north. So theoretically what this should do is over time we should end up with all the small ones at the bottom and the larger ones at the top. So if we run this, so you can see we're just yes, okay, so when we're at the top, we can't, yes, we need to know to not do that. So if we are, so if I plus 1 is less than the get world size, so I plus 1 is less than world size. So I think that should prevent us from doing the incorrect comparison. Yeah, so we shouldn't swap. So you can see that we're basically, it was bubble sorting, I think is basically what we're doing here. We're basically, it takes us many times over, but we managed to get everything big to the top. Now, we want so we want smallest to largest, but we also want smallest to largest that way. So if we basically copied that, we'll optimize this later, maybe, depending on how keen we are. But for now, if we go like this, and if we say, so before we move to the north, if we say j plus 1 is less than get world size, we can say this, and we can say east. East. if north cacti size, nope, so if we want if east cacti size is less than the current cacti size, then swap east. If we run that, so we should end up basically all the little ones here going all the way over to the biggest ones over there, I think. Yeah, so we're basically now in a good sorted spot. So it says, if all neighboring cacti to the north and east are fully grown and larger or equal in size, so now if we went basically and we did a harvest here, theoretically, at this point right now, if we did a harvest here, then we would harvest the whole board, I think is what it's told us. So if we do let's see this one here. So if we do so if I move that off to the side, so if we just do for simplicity's sake, if we do harvest, and we do a harvest, and then we run that, we think we will get everything all in one thing. So if we do harvest, or this one, okay, so we didn't end up, look at that. Oh, because it tilted the other way. I see. So now the question is, how many times do we want to how many times, if we're just doing the suboptimal, I mean, we could basically go and we could bump all of these over. If we bump all these over, then we can do an overarching for uh, do sorting iterations. And can we do it in, if we do it in get world size? So if we do this, just contemplating this out in my mind, this won't be optimal. Num sorting iterations equals 0. Num sorting iterations is less than get world size. We're going to do that, and then we want to basically when we move, I guess we can do it out one more right there. We can say num sorting iterations. I guess we can just do plus plus. I think we can just do plus plus. So if we run this, it's going to loop through and This is not a valid for loop. Oh yeah, okay. So for in, we can fix that syntax in range. So we don't need to do this, then it should automatically make that for loop work for us. Yep. So then if we just run the harvest, no, we did not. Okay, let's reset the board. Let's go and do this. So the question is, why did we not, why was that insufficient? Why did that result? So sort of if the cacti to the north and east are fully grown and larger or equal. So these should all be greater or equal. Greater or equal. And we know, because otherwise it would have kept moving them upwards. Because if we do the harvest, it doesn't do it. So if we reset, because we can do, because we could do this, we could easily say, basically copy that. We could do this twice, because we could say only do the north swaps first, and then only do the east swaps second. If we run that, going to go, everything's moving up, everything's up and good now. Then we're going to switch over. We're going to start moving everything I think we're good. So now if we harvest, yeah, it does everything. That's interesting. So somewhere in there, we ended up with one that was not harvest will only spread in sorted order. All neighboring cacti to the north and east are fully grown, which they are, and larger or equal in size. In the south and west are fully grown and all neighboring cacti. I think I know what it is. So if we go, let's reset this. Yeah. So I think it is just a subtlety in the ordering. Yeah. So anyways, so this works. I think we could optimize it further, but I don't know that it matters so much if we optimize it further. I'll have to look and see what we actually use the cacti for. Yeah, we're good. We're solid. So I'm curious, so if we moved this, do we basically have enough time to make sure that everything is fully grown? So that we can have it all in one file. So if we take that out, let's delete that. Yes, delete that. If we do a reset, we run this. Theoretically, I think everything should have time. Yeah, it'll work. Can have it all in one file. We could even just put the reset at the top. So make sure, I mean, or we could just make sure that we only till if we need to. Yeah, you basically don't end up with this pattern if you try to do the north and the east sorting in one. Makes sense. So if we do a clear, yeah, so you can say, move this, move this over. Is this that's my defined one, okay. That is good. I should just name this differently so I can mildly worried for a moment that I had gotten rid of this chunk of code. So the manage all resources. The cacti really add up in a hurry, which is nice. I don't know what thresholds we have for the values we need. It's nice that they don't take too long to get to a large number. So if we move that up here, go to unlocks. Is there something? Okay, there we needed the 3,500 cacti. So we increased the speed, so we will need more of those eventually. Dinosaurs need 4,000 pumpkins. We've got enough now. Dinosaurs are ancient, majestic creatures that can be farmed for ancient bones. That's probably the other thing. Unfortunately, dinosaurs have gone extinct a long time ago, so the best we can do now is dressing up as one. For this purpose, you have received the new dinosaur hat. This hat can be equipped with change hat. Unfortunately, it doesn't quite look like the one on the advertisement. If you equip the dinosaur hat and have enough pumpkins, an apple will automatically be purchased and placed under the drone. When the drone is over an apple and moves again, it will eat the apple and grow its tail by one. If you can afford it, a new apple will be purchased and placed in a random location. The apple cannot spawn if something else is planted where it wants to be. The tail of the dinosaur will be dragged behind the drone, filling the previous tiles the drone moved over. If a drone tries to move on top of the tail, the move will fail and it will return false. The last segment of the tail will move out of the way during the move so you can move onto it. Wow, okay, so this is definitely some more intense stuff. So when the hat is unequipped again and equipped, the tail will be harvested. You will receive bones equal to the tail length squared. And so then the move takes a lot longer. So what do we need? So is this just moving around the board then? Is that all we're really doing? Da, 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 da. Why are you being difficult? So if we just grab, so if we just grab that, so if we copy that, we create a new file. So let's call this dinosaur. Dinosaur bones, I guess, is really what we're doing. So we can say change hat to hats.dinosaur hat. And then we basically want to do this, but we're not going to do that. I'm not going to do any harvesting, basically. Maybe we do need to do the harvest to make sure it's clear underneath. So if we do that, and then if we were to change hat back to hats dot straw hat. So this won't do the looping around the board, but oh, that's not what I expected. Drone tries to move on top of the tail. It will fail. We're moving north, so if we reset, so we can't do the, wait a second, what am I missing? I am missing something. Okay, so we're not moving, so the north, basically it won't move off and do the back to bottom row that we were doing before. So basically we're gonna go north, then it just keeps doing the east because it keeps failing its norths. So basically if we can't move, so if move north, let's say if not move north, move move south. So if we do, yeah, so this is just slightly trickier. So if we can say, let's probably say while move north. So while move north, we will. So we can probably just put this in here if we needed to. So need to harvest, we always can harvest. So we move north while we can. I'm curious, obviously I think we're going to want to do our movement completely different here. So move north while you can. If you can harvest, harvest. Then what we want to do is we're going to say, so once we can't move north, we're going to move east. I know there'll be some subtleties to this, but we can deal with those in a moment. So we're going to move east. And then we're going to say while move south. And then we're going to move east. And then we're going to do it all again. So we go north, then we go east, then we go south, then we go east, then we go north, then we go east. So it's 1, 2, 3, 4. And we move east. Then we want to basically do that again. So this is not optimal, but if we do this, then we're more effective than we were. Because theoretically we could even do this, right? We could do the clear, and then we can even, no, I don't want breakpoint. I want to move that down, and we can say while true, do all the things. Obviously, we can make this wildly more efficient, but theoretically, this is going to Actually, I wonder if it's better to do the clear at the top, because then we basically don't have to, it just handles its own resetting. So it's not super efficient, and it only works going forward. So once the apple moves behind it, it doesn't get any return value for that. But this does function. This is going to give us the dinosaur bones. It's an ugly chunk of code, but like I said, it does accomplish things. It's just going to be, I mean, I guess ideally what you're looking for is you should be able to traverse the whole board until you can't move anymore, right? So if we, yeah, that's doing what we want. The question is, can we make it more efficient? I feel like the answer is yes. So let's get rid of the breakpoints. Let's go there. So if we say move north equals true, then if we say if move north, yes, if move north, then we do this. Else, we want to do this. So if we want to copy that there, we can indent that nicer. We can say that this basically we say move north equals not move. All right, well, now let's just say it's false. We don't need to do anything fancy. And this is move north is true. But there's the bit that we have in the middle. So we want to say, so now we want to say move east. Move east equals true. Nope, that's not what I wanted, true. Oh, I see. We got to capitalize true. We need to say false. And we need to say true. Then if we come here, we can say if move east then do this, and then we can say else move west. And the thing that we can do though is we can say if move east, if not move east, then move east equals false. And then we can say if not move west, move west, move east equals true. True. And then we can theoretically get rid of that. So if when we come into this, we do the clear rather than in the loop. So if we do the clear there, and we change to the dinosaur hat before we go in. So then we will keep looping over this, so we'll move all the way north. And then once we're done moving north, we'll fall out, we'll move east, then we'll fall out, and then we'll come back around. So this needs to come back to straw hat. It's going to be outside of the loop. So we can say did move equals true. So while did move, basically we're saying while we can still move, we will keep doing all of this stuff that we're talking about here. The difference is, so while move, so when we come inside this, we want to say did move equals false. And then we only want to say that we moved if we actually managed to move somewhere. So we'd say true. We can do the harvest still, that's fine. Else did move equals true. Then we can say if move. Then we can say did move equals true. Else move east equals false. If move, so now the question is going to become if move west, that did move equals true. Else east is true. So the only question then, do we need to say if move east? If we fail here, then we need to immediately try going west, right? So if we move, that's cool. We did the move. We're true. We're going to come back around. Else, we need to try right away to see if we can get to the west then. So else, if move west, that did move equals true. Else, move east is false. And if this one, so if we tried to move to the west, we did move, that's good. Else, we need to move east. Then did move equals true. Else move east equals true. Do I need that else? Don't think I need that else. I think we just want to set that value regardless. So if we come back to there, that's a lot of changes. I think that makes sense in my head. So let's see if this actually, no, beginning of the code block. Which code block? Which code block did we forget? Oh, yeah, okay, right there. So what we would expect here is to get a max length dinosaur before we... So now this still isn't optimal because it's forcing it to walk the entire grid over and over and over again. So the thing that it does there, basically once your tail ends up a certain length, so we're not going to end up in the max case because the, let's see, so this is going to grow. Because it's not doing tail management either. We're not figuring out how best to sort of orient ourselves so that we don't run into our tail. I feel like we could do some stuff there. But this is going to basically mean that we are longer than we've been. Yeah, we're doing pretty good. I feel pretty happy about that. What are we using these? What are we using the? Oh yeah, okay. We need 1,000 of them now to expand the farm again. So how do we, what is the next thing? So if we come back here, so we kind of want to do the manage all resources again, I think, because we basically need to soup up our pumpkins. This should allow us to do that. Because we should convert over in a second to getting, once we get back over 1,000 wood. Yeah, now we're on pumpkin duty until we're under 1,000. Okay. So we are running again in resource gathering mode. I'm going to leave the dinosaurs for the time being. I think we'll leave the census for the time being. I think we're good there. I think we just want to, what is it doing now? What are we, stop, reset, manage all. We're in carrot mode. We're back in. Because we're probably getting confused about growing things for the pumpkins. No, let's see, some pumpkins are good. Probably gonna run into carrots though. Is that where it goes awry? Yeah, it starts bouncing all over the place. When it pops back to the carrots. So why are we out of control? So let's reset this. Now, if we run this, we're going to be doing getting the lumber and the, so let's put a breakpoint there when we get back to the pumpkins, because I feel like that is where things went awry, because we're okay. So now we're getting carrots. We're doing carrots. Everybody loves carrots. Carrots. More carrots, because we were out. Yeah, we were still under 1,000. Now we're doing this. That's fine. Getting more of our wood and hay. Okay, so now we're doing pumpkins. So I think we're okay for the first time through pumpkins. I think we're okay until we run out of, or until our carrots drop. Okay, and so the issue is that we aren't going and so if we go, because I think what we're expecting, so I think we get confused because of the fact that we harvest, we plant the carrots, we move north. Can't harvest. So if we can't harvest, so that's okay. So now we're in this spot where we really want to do the harvest if we can. If not, then we want to plant. Or, well, regardless, if we harvest or not, we want to plant. We don't want to tie that because basically pumpkins can take up more than one space. So you do the harvest, it opens up a whole swath territory. So this should sort it out. Definitely a lot of subtleties here as you go through, depending on how you set your code up. Now we should get lots of carrots, and then we should go back to getting the hay and the wood. So we're going to do lots of that to the point where we can then go and do pumpkins again. At which point we should then return to carrots, and then we should be able to see everything working. So yeah, we're on to pumpkins. Carrot numbers are going down, 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 down. Now should see, yes, everything working the way we want it to. So that's working. What do we need in terms of unlocks? Lots of treasure. lists, import things from other files, min, max, absolute, random. We grab mazes. What are mazes? How does this work? Weird substance has a strange effect on bushes. If the drone is over a bush and you call use item weird substance, the bush will grow into a maze of hedges. The size of the maze depends on the amount of weird substance used. The second argument of the use item call. Without maze upgrades, using n weird substance will result in an n by n maze. For each maze upgrade level, you need to use an extra n weird substance to get the same effect. So to make a full field maze, plant, bush, substance, get world size times num unlocked, use item. For some reason, the drone can't fly over the hedges, even though they don't look that high. There is a treasure hidden somewhere in the hedge. Use harvest on the treasure to receive gold equal to the number or to the area of the maze. For example, a 5 by 5 maze will yield 25 gold. Oh my goodness. So same maze can be solved a maximum of 300 times. That is bonkers. So we are going to want to stop that, clear that. Let's go back to this for a second. So we are going to want to new code file for maze. Create and run maze. So we are going to want to, we're going to need weird substance. And the weird substance comes from the fertilizing to if we this out here, if we go if we do this, so if we create, let's see, so we say need weird substance. Then if we expand that out, so if we do while true, we paste this in, we also, let's do here, let's use item, items dot fertilizer. Oh yeah, we need the colon. Let's see what we can make happen with this. Can we start to get Yeah, we're starting to rack up the weird substance. That's good. Very interesting how they intertwine all of these together. So if we stop this, I think we've got enough weird substance for now. So if we were to do what they said, so let's reset. Let's do plant entities dot bush. Then if we do n substance equals get world size times num unlocks dot mazes. So this will tell us how much of the substance we need. So use items dot weird substance. And we go n substance. So theoretically, that should create a maze. No. Unlocks auto unlock must be unlocked before this can be used. Unlocks auto unlock. What is that? Auto unlock. Automatically unlock things. So lists is 1,000 carats. Store multiple values. Okay, that's fine. Let's see, what's the next one? We did lists, now we got dictionaries, but what we need is more resources. Okay, so that's fine. We can't do that. Let's do the reset, and then let's do resources, and we'll come back in a few minutes when this is all done. When this is all, we've got the resources we need to unlock everything. So you can see we're just spinning resources, collecting, harvesting, moving to the next one, collecting, harvesting. In the unlocks, I've managed to unlock lists, dictionaries, costs, all of which just are helpful things potentially for, new functionality or new ways we might want to solve some of the problems. For auto unlock, which we need for that maze code that we were looking at, we need 10,000 dinosaur bones. So that's going to take a little bit. I think what I'm going to do here, you can see I've also been upgrading the yield of our grass. So we're up to 1,000% there. Been working on the trees, which are up to 300. I think what we will need to do is we just need to spin this for a super long time, and then we can probably come back and do a final video to kind of close this game out and work on solving the mazes and do these last little bits here with the leaderboard, polyculture. Um, we need to debug 2. We need the maze to get that. So I think that pretty happy with where we've managed to get to today. It's been a lot of gameplay, but really starting to optimize things via, some of the new functionality that we have with functions. I think the imports, that's the other thing. We unlocked imports and utilities. So we've got a lot of capability at our fingertips now. We can theoretically call, import these other files and utilize the functions in there, so we don't have to have everything in the one manage all. So, happy with what we've managed to do. I'd like to optimize these pumpkins too so that we get the Uber pumpkin. So there's definitely some things that we can do in one sort of final video on the game. But like I've said, this is a really impressive game. Really cool to see the depth that they've gone to here with the programming options that they put at your fingertips and how they sort of scale things up over time. Really impressive to see, and it's been fun to play as well, even though it is getting a bit grindy at this point. But I think we will leave it there. Thank you very much for watching. If you have not subscribed to the channel, please make sure to do so that you don't miss out on any of our upcoming videos. And thank you very much for watching. We will see you again soon. Take care. Bye.